Hi, this is Professor Kleitz, and now I want to create a vector waveform file to show you how to simulate that design, that Boolean 1 design, which was x equals AB or CD. And what we should see for the output is that the output goes high at x whenever we have a high A and B, or if we have a high C and D. So the first thing we need to do is to go to File, New, and what we'll select is the University Program Vector Waveform file. And right away what I usually like to do is do a save on this. So we'll just say File, Save As, and it's going in the Boolean 1 subdirectory, and we'll use the name Boolean 1. Oh, I got caps lock on. Let me get rid of that. Boolean 1, lowercase, say save. And there's our file name is boolean1.vwf. So right away what we want to do is set up the scaling on this. So we'll go to Edit, and what we'll do first is set the end time, and we'll choose 16 microseconds. Press OK, and then we want to set up the grid size for the clock waveform, and we'll set that up as 1 microsecond. And you can see we're going from 0 up to 16 microseconds. So if you don't see all the waveforms, let me go back to the simulation. If you don't see all 16 microseconds, you would go to View, Fit in Window, and it makes sure that we get all 16 microseconds to fit in there. Now to get the waveforms, under the column name, you right click, Insert Node or Bus, and we select Node Finder. And if we just press List, it'll list all of the inputs and the single output that we created when we did the compile earlier. And you select all 5 of these, and you press the right hand arrow, and it sends them over to the selected nodes area. And when you say OK, it places all, and you say OK a second time, it places all of the nodes on the simulation waveform editor. Now what we want to do is create the waveforms. So what we'll do is just create a series of waveforms that count up from 0 up to 16. So if you right click on the A waveform, so I'm sorry, I meant to say you left click on the A waveform and say Edit, Value, Overwrite Clock, and we'll set this up as 2 microsecond period, and you'll see the first set of waveforms. The B waveform, left click, Edit, Value, Overwrite Clock, 4 microseconds, and the C will be 8 microseconds. And finally the D, (16 microseconds). So if you look at the 4 waveforms, you'll see it's a counter, 0, 0, 0, 0, and then we have 1 in the least significant bit. So it's 1, 0, 0, 0, and then we have the number 2, and then the 1, 1 is a 3, and so on. And this way we'll count up through all 16 possible combinations. So again, I'll say File, Save, and this VWF file has an asterisk next to it. As soon as I say save, that means that we've done work on it and we haven't saved it yet. So we'll say save, the asterisk goes away, and now we're ready to run a functional simulation. So now when we press the simulation key and run functional simulation, it goes through a series of creation of several new files to create this simulation, and it'll actually show us the output after a few seconds. And here is the final output, and this is called the simulation waveform editor, and this is a read-only file. It's just here for us to look at the output, and let's see if this worked correctly. First of all, let's say view fit in window, and I see the waveforms are not aligned perfectly as they were in the VWF. So when I run the simulation, and if I blow this up enough to see it, we end up getting skewed a little bit. What we have to do is go to edit grid size and set this back at 1 microsecond again. It changed after it went through that simulation. Now everything's lined up nicely on in the grids just the way we like to see them. So let's take a look at this output right here. Why did this go high? Because we had a high A and a high B. Why did this one go high? Because we had a high A and a high B. Over here we have a high A and a high B. This period right here we've got a high C with a high D, a high C with a high D, a high C with a high D, all the way down through. So this simulation waveform has proven that our Boolean equation is working properly. Now we'll be ready to program this onto an actual board.